Hey there guys, welcome back to a brand new video. So today we are going to be evaluating the integral from 0 to infinity of 1 over e to the x plus 1 dx, step by step. So let's get straight into it. So let's go ahead and let's make a substitution. Let's start with a substitution. Let's just try this, see if that works. Let's allow u to equal e to the x plus 1. And that way we get du dx is equal to e to the x. Now this doesn't really help us at the moment, but what we can do is we can look at this term here and we can subtract 1 from both sides, and that would allow u minus 1 to equal e to the x, and then we can actually substitute it here and substitute it into our integral in terms of u. So let me show you guys what I mean. So we get du dx is equal to u minus 1. Okay? And now let's rearrange for dx. So here we get dx is equal to du over u minus 1. Okay? So we've got our u substitution and we've got this fact right here. So let's go ahead and change the limits for our integral. So for 0, we get from e to the 0 plus 1. So our limit for u would equal 2, and e to the x plus 1 as it approaches infinity, it also diverges, so it's infinity. So 2u is equal to infinity. So basically we're evaluating the integral as u is equal to 2 to u is equal to infinity of 1 over u multiplied by du over u minus 1. And we can actually solve this integral, unlike this integral directly. And that is using partial fractions. So let's look at this statement here, just separately for a second, instead of looking at it in the integral. Say v was to equal 1 over u multiplied by u minus 1. How can we separate this from one another? Well, we can use the idea of partial fractions, as I said. So that's a plus b divided by u and divide by u minus 1. And now we can combine the fractions by cross multiplying, and we can make a system of equations using this fact. So we get a u minus 1 on this side plus bu on that side, all divided by u minus 1. And that's what we want. So we want to prove that we can find values in a and b for that this is satisfied. So we're trying to find values of a and b such that this is satisfied. So we can separate the u part from the constant part, and we get this. Divided by u multiplied by u minus 1. Okay? So we get that. Okay, that's helpful. Let me pull it up a bit. So that's useful. We know that we have no u part, so we can set that equal to 0 because we want the partial to equal this here. So a plus b is equal to 0. But we also know that the constant part has to be 1. So minus a is going to be 1. And from that, we actually get a is equal to minus 1. And that means b is equal to 1. And that satisfies the conditions of both the simultaneous equations that were formed from the partial fraction method. So that means v is indeed equal to 1 over u multiplied by u plus 1 minus 1. And that is also equal to minus 1 over u plus 1 over u minus 1. Okay? And now we can actually substitute this into our integral. So we get the integral from 2 to infinity of 1 over u minus 1 subtract minus 1 over u du, and we can evaluate the integral, and we get the natural log of u minus 1 take away the natural log of u, and by the method of combining the two logs, let's just make sure we put the limits in from 2 to infinity. But by combining the logs, we can simplify this statement to get the natural log of u minus 1 over u from infinity to 2, and that is the natural log of 1 take away 1 over u from 2 to infinity. And now we can plug these in, and what we get is fairly interesting. So as this here tends to infinity, the fractional part here is going to tend to 0, because 1 over infinity, any constant over infinity, will equal 0. So that converges to the natural log of 1. So we get the natural log of 1 take away, and as we put 2 in, we get the natural log of 1 minus a half, so we get the natural log of a half. And of course, we know that the natural log of 1 is just 0, and we get minus the natural log of a half still here. And that simplifies by bringing that in to the natural log of 2. So that is our answer. The integral of this is indeed equal to the natural log of 2. So guys, I hope you guys enjoyed this wee video. Remember to leave a thumbs up if you enjoyed it. I think I might try and do my videos like this from now on instead of using my Surface Pro, because I feel like I can concentrate more and I feel like I have more interaction with you guys, even though I don't have an audience at all. So remember to subscribe if you're watching this video. It would be much appreciated. Trying to grow a community, but it's not required. I'm just doing this because I enjoy math and I really want to share my math motivation with you guys. And I'll see you guys in the next video.